Okay, so I'll share my screen then.
Yeah, sure. In the meantime, Venkat or Harish, if you want to add something that we haven't spoken, feel free to, because I don't want this to be just me and Krishnan. You're welcome to join in.
Yeah, sure.
Yeah.
Okay, I'm just going to turn off my camera to save on bandwidth because this is complaining.
Yeah, same. Yeah, same here. So what we were discussing was we looked at this M5 competition on Kaggle, which was there a few months back, and we looked at the data set which is from Walmart in the US. It comes from 3 different states, Texas, Wisconsin, and California, and it contains about 3,000 products in 3 categories and 7 product departments. So what they have done is they have given 3 files, or rather for us to work with, 3 files they have given. The first file contains the data, the temporal information along with cultural information, which means they have date, work, weekday, etc. They have a specific way of marking a few aspects. We'll come to that. And then they have some event-related information whether it is it's a religious festival or Easter and things like that they have. And then they have something to do with where the purchase was made, etc. Whether that purchase was made in California, Texas, or Wisconsin. And then there is another file which contains the store ID, item ID, and then the sell price. So they have kind of separated this. We were talking about putting them together. We don't know exactly yet. We'll probably have to figure it out. And then the sales ID, again, there is another one where they are giving what was sold when, how many days. And this sales data is what we have to predict for 28 days. Starting, I think it starts from.
So if you just scroll down a little, if you see there, no, just that last line. See, D1, D2, all the way to D1941. So it's basically three years of data. So 365 and 3 is probably that much, or is it something different?
No, 5 years in fact.
5 years, is it? Yeah.
So 365 would be like 940. So this is 1940.
No, that's because it will be. I'm just trying to see because we have 3 stores.
This is the data period.
Right. See, that's the products and maximum selling history of 19,412 days. And if you just go up again, just to that, what is that thing? Just D1, D2, D1 to 1940, number of units sold a day I starting from this. Okay, so you see, it's like they seem to have these 1941 days, right? And they have put for every unit, they have put like so many were sold on that day. So it's like you see item ID, department ID, cat ID, and there's whatever it is. So how does it come to be 1941? I'm not exactly sure. Starting from this much till 2000.
No, I think this is wrong. Yeah, I think it's only 4. No, this one. You see that there are 5 years of data. Okay, so
then I think it should be.
Yeah, that's what I'm saying.
Okay, then that's okay. So that means it's like that is very messy kind. I don't know why they did that, because it would have been simpler if they just had like a whole row, right? Or if you had like all the sales data for every day, and just that they should have said, okay, what has been sold. For some reason, this one, because I think that's just how the Excel sheet must have turned out. They had these Excel sheet, they kind of just rolled it out. So we will have to somehow figure out from these how much it is sold. But anyway, let's keep going. What were you saying? Yeah.
And then, this is just how these. So you can see these items until 3049 here. So these have been classified to each, shop, in fact. So there is some classification they use. Each shop has, there are 3049 items, and for each shop, it's the same. So it's not like an item that you consider in California is not in Texas or anything of that sort. It can be in any of the 10 odd shops. Okay, so this is what we have, and we started looking at the data, and the calendar data is something like this. So I just look to the tail, and these are the events and all. So what we can probably do is start doing is to prepare these features, and the other one was let me just look at the other one. We also looked at these factors like, okay, what are the unique days and all that, but these we'll probably see it later. So I think we can have a quick look at the sell prices as well.
Yeah, so what I was thinking is, so basically, like for example, see there's this data above, which is like all those, what are the events and all that, right? If you go up a little.
Yes.
So there are these events. Now, if you look at the event number, I think there were two types of events. If you look at event number, where was that again? No, you had done it already. Scroll down a little. I think you had already done that. So if you go, so if you look, there's the first, this above. So there's like two types of events, event name 1, event name 2, right? So now if you look at event name 1, how many of them are there?
So there are different, okay, event name 1, there are about what? Let's see. 31.
Okay, and event name 2?
TU2 is 4.
Okay. So
I mean, I think the only reason why they had event name 2 is that on some occasions, there are more than one events on a particular day, and they had to introduce this so that they can distinguish between them. Like for instance, here you see that Orthodox Easter is coinciding with Easter, and then it's coinciding with Cinco de Mayo. Similarly, NBA Finals.
What I'm actually thinking, the question is, what we have to say is, if we want to use any of these 4 columns, we have to now see how much data is actually there. So for example, if we look at how many in event name 1 are that is not any. So like if you run this number 16 for event name 1 and check. So now you see
162 rows.
162. So then the thing is like this, if we have only 162, there's not much you can do to use it, right? Because the data that you have is actually minuscule. You can't do much with this kind of data, at least like trying to predict if anything happened on that day, because it's too little. So what I would say is, rather than trying to use these event types, we just focus on the items, right? So we try to focus on the items and try to see and try to do some kind of sales analysis using just items and the time data.
Yeah.
Because we have the
one thing we can do. At most one thing we can do is that we'll just convert the entire thing, because it's like this is 162. Let's say we want to use it as well. We'll put all these 4 together into a single column where we say that it's 1 or 0 depending upon whether it's an event or not.
Yeah, that's also okay.
Yeah, so we can do a sort of encoding of these 4 columns, or I would say we just need to look at, let's say these 4 columns. We'll say essentially event name 1 and event name 2. We will say we don't want to right now worry about what is the name of the event, but just that there is an event.
Right. Yeah, that's also good. We don't need the details.
So I will just do this then. Okay, so it should be something like, okay, let's do it here. DF calendar. So we'll have to say that this one is false. So we don't need. We'll have to now get the indexes, right? Or rather, we'll just do an encoding.
Yep.
because it has either NaN.
Exactly.
So if it is NaN, we'll put it 0. If it's not NaN, we'll put it 1.
Yeah, and you can do an OR because in case between number, if what do you call it?
Yes.
If event name 1 or event name 2 is there.
Okay, so we'll say. I think the thing is the entries where event name 2 is not NaN. Is all the entries where event name 1 is not NaN. So it's not going to anyway. We will do that anyway. So okay, we have this dot is now equal to false, and you'll have to do an OR with this. Yeah, I guess
that won't work actually. You have to do a cast, so you have to put a pipe instead of an OR.
Okay.
Because you'll eventually put it to the DF calendar. So
yeah, so we'll create a new column in DF calendar. So let's say we call it events. We will make all the entries to 0, for instance.
Okay. Now, actually, what I would say, first what I would say is just run that query, like for example the one which you put before up to now. Yeah, just put this to DF calendar and see what you get. Is it the same as the other one? Or is it a... Oh, you have to put them in... no, you have to put each query in a parenthesis. This is something in pandas. I don't really know why. So within... each query. Yeah. And then separated with that pipe. Yeah.
Okay.
This is something
it's
specific.
The same 162 rows.
Okay, fine. Okay. So then this sort of... So we can now just... Then in that case, we can just... What I would say is we can do a quick this thing. You can write a little function and do an apply if you want.
Okay.
So what you can do is, see, basically it's like this. We are interested only in 4 columns, right? So since we are interested in 4 columns, we can apply our function to just these 4 columns. So first what you can do, you can take like DF calendar and select these 4 columns as a sublist. So,
okay. So what do you want as a sublist? What do you want to do?
That is event name 1, event name 2, event name 3, that is event type 1, all those, just 4 ones, or rather just event name 1 and 2, just event name 1 and 2.
Yeah. So it has to be another.
That's the thing, another list. Okay, so here to this we do an apply. So you can do an apply on this. And here you have to now, first you have to say axis is equal to 1 because we are going to that is the next, that is actually axis is equal to 1 is the, now here the first one will be the function. Now what we can do, we can just put like another cell and we can add the function. So define a function, anything, def, whatever. Event sorting or event filtering, encoding, and you need an X. So here you can now extract the 2. So it will be X is event name 1 and event name 2 are available in X because we are applying the axis. So what you have to say is, you just have to say that if you can write that query, so like if X of this is NA, that is event name 1 and event name 2, if either of these are.
So I copy this and sorry, one more. This is how is it?
No, that won't do. Basically you're doing an OR, right? So each one you're just checking if this is NA. Is NA.
Okay, it's the same thing like here.
Yeah, exactly.
Okay, let me just instead of default calendar, I should have an X.
Okay. And here you probably will have to change that to an OR, actual OR, because now this is within,
Yeah.
So
this,
so here, if it is the case, you can return, let's say, a 1.
Yeah.
Else return a 0.
Yeah.
Right?
Yeah.
So now if you apply, use this function,
and then put
give it a new name. So like, for example, just say event. You can maybe just say event actually. Yeah, diff events.
Yeah. Is not an attribute. Okay. So what is because
no, I didn't see it. Can you come down to show me what that is?
Float attribute has no attribute isna. So this is considering it as a float. It is going as an independent. Okay.
I didn't get it. Okay, go ahead. Tell me what it is.
Look, so what is happening is it says that float attribute has a float object has no attribute isna. Essentially, it says here x. This one is it is considering it as isna. The thing is because that's an independent. I mean that's a individual element of the pandas data frame, right? So we'll have to check for a given number. Let's say I say that a is equal to 5 dot, and then what? Okay, and then I want to say a dot is integer or something like. Okay, is there something called is nan?
I think so. I think so. Just see np is nan. I think you have to say np dot just do np and then say is something nan. Yeah.
Okay. So it should be this.
Okay.
Should use this, I think.
Yeah. Okay.
Okay, and okay, let's see what happens now. Now it's another issue. Isnan is not supported for the inputs life, and the inputs could not be safely coerced to any supported types according to the casting rule safe. Is nan not supported for the input types? Okay. Look, I'm not really sure what exactly is x at this moment. Let me just try that, perhaps.
Okay, sure. Just print it out.
Print x, because I'm not really sure what is x at this moment in this kind of situation. So x is fine, nan. So x has, I'm not really sure. Okay, type of x, maybe I should.
Okay, try. Basically, it's an object.
Yeah, it says it's an object.
So now, I'll just like, for example, what this apparently, I think what it's trying to do is that it is saying that if this event name, what you call event name 1 or 2 is not nan, is a string instead, then I think it doesn't know what to do with it. So what we can do is you can put this in a try except block. So for example,
yes.
So do a try, yeah.
Okay, so try.
Just
I see what you mean. Yes. First, in fact, because it is nan, it thinks it's a float.
Yeah.
And then when it is not nan, it's a string, and then it's like, dude, I can't deal with that.
Yeah, exactly. So just try colon.
Okay. Try.
No, it's just colon. So basically, whatever comes within, it's just trying it out.
Yeah. Sorry, you put it like this?
Yeah, colon. It's a new block.
I'm sorry?
I mean, yeah, that's it. It's just the conditional block. So there's basically whatever is there can continue. And then this is if everything works, no problem. So it's just tab it in. And then there is an except block. So what happens is if there is an except, now the except happens, when it happens is if this fails, that usually fails when it means it's a string. Now in that case, you have to return 1 because that means that you are indeed having a string. So what you can do is...
because this doesn't make sense because this is never going to happen then.
No, that's the thing. So like it will check it. If it says, what it says is NP is nan X event name. Now let's say X event name is Easter, right? So therefore it now NP is nan will fail. So if you go up, if you just try it out before in the previous cell, just type NP is nan in hello and pass it hello and see what happens.
This one?
Yeah. So basically it's a function, it's a method. So you can call hello. So if you see there's an error. Now if you put instead np.nan. See now it's true. Put 5, it should be false. So you see, so basically if it is a string, then there is an exception. So then in that case, it means you return 1 because it is indeed an event. It's a string. So then we return 1 because it's an event encoding, it is an event.
Yes.
Okay. Actually, so only like you said is the NP is none never happens. So it's like, if
But anyway, it doesn't matter for us. This is a way to solve this problem.
Yeah. Because, well, it's just that in our case, this happens very rarely. So computationally, it's not really a nightmare because most of the times it is nan. So the return 1 usually does happen. Is the else block that never really happens. So instead of the else, it goes to the exception.
Wait. Look, this one happens
162 times.
This one, there will be an exception in 162 times. So it will go here.
Yes.
Most of the time, then it will go here and then just be done with it, right?
Right.
Okay. Yeah. So it seems fine. Okay. I will just check the DF calendar. So I will just see at the end there is an events this thing. I will just check if the events. I'll check this part. It'll be interesting to see if the events calendar. So the events are all 1 here. See?
Yeah.
Oh, because this is the time when there is an event happening.
All right.
Okay. So do you think we'll remove these things, all these events?
I think we can now extract. What we can do, we can extract another data frame and pick out what we want.
Yeah, exactly. That will do. So this, and then with respect to Snap CA and all, I'm guessing it has to do with where it was bought. But no, there was something else it was there because there's like 3 of them. There's something else was there. I will have to check what is this. Just a second. We'll see what this snap means. A binary variable indicating whether the stores of CATX allow snap3 purchases on examined dates. 1 indicates snap purchases are allowed. Do you know what snap purchases are?
Snap. No, I don't really know actually.
Yeah, I have never heard of what does it mean. So I'm not able to make sense of what snap purchase is. Snap is this. Okay, now I see. Snap has to do with the sort of a food coupons that the government gives for low-income people.
Okay. Right. Okay.
Yeah. Whether the stores will allow Snap3 purchases on the examined date. 1 indicates Snap purchases are allowed. So yes. So which means that household items might be bought on Snap days Whereas, some of them may not be bought. So it's likely because, if they don't allow you to buy stuffs, people may not buy a lot of some of those stuffs.
Right.
So
Okay.
it might be useful to predict some of them. So it's probably useful.
Okay.
Okay. So then we can probably also transform this weekday. I think we don't need this weekday or not, because you see that W day essentially shows us that.
Exactly.
So we don't need that. And this WM year work, I think we will be required to do some synchronization, but as such, we don't need it. And date, we may have to transform it into a date time column.
Right.
Because it's probably useful for us if we want to look at the dates. So it might be like, for instance, if we want to look at whether it's the start of the month and all that.
Right.
Useful. So yeah, so then we will, and then this is required. Do you think the month and year, day, time will be, because once you put the date, I think we don't need month, year detail.
No, you wouldn't.
Yeah, I mean, week, the day of the week is useful, and we can, if we want, we can even do some sort of engineering where we say that's
okay.
Weekends
now, do you see that column D?
Yeah.
Now you see D9. Those are the same encodings that you find in that thing.
Yeah.
In that, so it's like actually that is the day number.
Yes.
I see.
So here it goes up to 1969 because in the sales data they don't give you the last 28 days. So there you only have 1941.
I see.
So this is required for some form of synchronization, I would say.
Yeah. So what I'm thinking is we can just use that date, and we need like you said, WM, YR, WK. We need that for synchronization. We then can keep that D column and throw out everything else, because the D column is what we really need.
Yeah, definitely. No, and then I think weekday, the W day column will be required for us.
Yes, of course. If you want to predict, like, whether it's a weekend purchase or a weekday purchase.
Yeah.
Okay, that sounds fine.
Required, and then the sporting column. And then maybe Snap we can keep.
Yeah, Snap we can keep. Yeah. Okay, sounds good.
Okay, so we will create a new calendar.
Actually, you can create like first a copy, so it can be DF calendar. No, you can continue. Keep going. DF calendar.
Yeah.
Because it might be easier to just drop columns than to actually pick out. So DF calendar, and then you do a copy. You just do a shift tab. Let's see if there's any options. So it's just saying, give me inside shift tab inside that copy thing. Deep is okay. Then it's good. It's a deep copy basically. Of course, though we don't have embedded objects, because it's like this. When you have an embedded object, the object is usually referenced. So, but we just have strings, so that's okay.
Yeah, okay. This is drop, and then you give columns in this form?
Yep, shift tab. Just do shift tab, you'll get the columns. Most, I think you'll have to say columns equal to and list.
Okay. It will be a list of lists?
Yeah, no, just a list, because here it's just specifying a list of strings.
Okay, so weekday.
Actually, you might want to copy it because it's very sensitive.
Yeah, because it's not.
Just go to DF calendar. Just have another one above. Just insert another column, another cell. Sorry, and just say DF calendar dot columns. Yeah.
So we need weekday. We don't need this. We don't need year. We need D. We don't need events. 4 of these. And date. Yeah, we will keep date.
Right? Yeah, I think so. We'll convert it if necessary.
Because right now I don't know, but we'll probably keep it. I think we'll have to do in place is equal to true.
In place is equal to true, yes. Yeah, I keep forgetting. Yeah, okay. That's good.
Okay.
Yeah.
So you have a smaller data set. Maybe I think we'll have to check what is
So now,
type of.
Yeah, go ahead. Yeah, type of this.
I just want to see the type of date. Oops. No. Okay. Date is an object. So we can probably convert it into a datetime object if we need it, but I think we'll probably think of it.
Yeah, sure. For now we can do. What I would say right now is, now that we've cleaned up this, the next one we need to do is we can check out this one, the other two data frames.
Yes. So I don't think we need all these now. This. Okay, so I think we have already done this. I'll just do it once more. Yeah, so sell prices is mentioned based on the week and the item IDs. So we'll probably have to see what these item IDs are, how many different of them are.
Okay, so now just 1 minute. Let's take a look at this. Let's compare these two. So you have store ID, item ID, and you have this. Now can you go up to the previous one?
Yeah, just a second. I'll put that as well here. Yeah.
So here we have. So this is only calendar dates. That's it, right? Only calendar.
Yes.
So now if we come down to the next one, this is actual sales data, right? Now, what I'm thinking is, what would be wiser? Supposing we want to combine these two, right?
Yeah.
Supposing. In that case, how do we go about it? We can bring. Should we bring the date in?
I would rather say that. Look, just a second. So I would rather prefer if we look at the other one as well, because
Let's check it out.
That's what makes sense, because I'll just check what is that. List. So it was sales train evaluation, I think. Yeah. So yeah, and in fact the validation data set was not supposed to be available at the start. It was only available after the end of the competition.
Exactly.
Or something like that. There was a period where the validation data was not available. That's why they have two of them.
Yeah.
But anyway, so let's say sales train we already have. Okay, let me see.
I think you just have to make that evaluation instead.
Yeah. Oh yeah. I'll have to do. Okay. Oh god, this is taking time. Maybe. Okay. I'll have to do an evaluation.
No, you can just change that, because we can sort of. Okay, we can.
Yeah.
Because we can this evaluation is okay.
Yeah. That's going to take some time. Yeah, it has taken some time. So yeah, so we have 1947 columns, and my guess is the 1947 1, 2, 3, 4, 5, 6 are these extra columns, and then you have 1941 days.
That sounds good.
So yeah, on each of the days, whether this specific item was there is an ID of the component, and an item ID, then the department ID and the categories IDs, and maybe what we can even do perhaps is so here they have only item IDs.
So I'm just thinking, if you look at the item ID and you look at the ID, so the ID is probably just something for that particular this thing, what do you call? Now the only thing what I'm saying is, if you see, it's only California.
No, it should be there.
Because you're taking the head, of course, it's the head. If you take, let's say, 10 or 20, put head, head you just put 10 or 20.
Or I'll just put everything so that it'll show the bottom. So you see Wisconsin as well.
Okay, good. Okay, so this is good. So then what this means is, for example, we have 30,000. Okay, that's good enough data. Now, now actually we've been talking a while. Let's do a little bit of brainstorming here about how we want to use this data. Anybody else wants to join in, feel free to. You don't have to leave this to us or something like that.
So, since you have told that you added a new column that saying that suppose if any event is there, then we are converting it into 1, not it is 0. I can say suppose we have a very limited number of events, right? I mean 20 or 10 maybe. So why can't we number it as 1, 2, 3, 4, 5, 6?
I think that is a suggestion. The only problem is the only reason why I even created that column is just because let us keep it. We were actually thinking of throwing it because it's like this. There are only 162 columns or 162 data points where there is an event, right? Now, with only 162, there is not much of analysis we can do about anything, either within that events or even whether there is an event or not, because it's too little. So let's say, for example, we had 1 million data points, and out of the million we had, let's say, 50,000 events. Then we can do some analysis to find out how the events themselves are, because now we have sizable data. But the problem is, if we have only 162 data points, we actually can throw it away. The only reason for creating that encoding is just to at least keep that information. So we could encode further. We could say that we can actually create 1, 2, 3, 4, and then we can at least say that if there was no event, it is 0. If there was an event, we can give it a code. So then if at all we need to check, we can check if event is equal to 0, in which case we know that there was no event. And event is greater than 0, then it is an event.
Yeah, I thought suppose the sales will vary according to the event also. That's why I asked that question.
Yeah, you can do that.
That is true. In fact, that is true. But I think for us it might be too little.
Exactly.
And we might not be able to. So right now that's what we are thinking. Maybe it will happen. We will see it later.
Yeah, so actually like what he's saying, if you want to do that, what we can do is we can create a map. So basically what you have to do is take the unique values of that those events. So let's say there are like, I don't know how many, 16 or 20 or whatever events. We can take those unique values and create a dictionary with each of them being mapped to an integer value, or vice versa, like an integer value mapped to that. So when you assign those integer values in the event, we can always use the integer value to look up the corresponding event name. That is all we can do. We can do that.
Since the accuracy will increase, depends on the kind of event which we take. I mean, suppose if you take 0 and 1, the accuracy won't be that good. I felt that way.
Yeah. I mean, it's like this. If we are actually doing hardcore analysis on event types, let's say, for example, each of these had an event, right? So let's say, for example, we have 30,000 events, then definitely we have to encode, because then it is like we are throwing away very valuable data. So then yes, definitely we have to go ahead and encode. But for now, initially in the beginning, we can start with this. I mean, this is data science. This is how data analysis is. There's no hard and fast rule. We just have to slowly keep trying different things. Anyone, anything else? So what I am thinking is this. If we can create one master data set, right, and use that for all our calculators, use that for everything, then in that case, here we have all the dates, exact dates on which a sale was made, right?
Yes.
Now, we have here the item ID, department ID, category ID. Besides this, we also can say, like for example, for each day we have, like all the days we have things like the calendar date, we have the week, month and everything else, right?
Yeah.
So if we want, right, let's say I'm just thinking, okay, this is sales train data. The previous one was sell data, right? So if you go back to that, so if you go to the previous one, so here you see there is a sell price. We can combine these two sell prices with the other one to determine exactly what we want. So what I'm thinking is this. If we look at this one, this WMYRWK, right, and the item ID are indications of how much, because the sale price can actually change, right? Because we cannot say that a unit at a particular ID has a specific price all the time. There is a discount, there may be a higher price, everything. So we can take the item ID and the WMYR, this thing, and we have the store ID, the second one. If you look at the DF sales train, we have these three columns: store ID, item ID, and we don't have the WM. So you see, we have these two, but we don't have WMYR, WK, right?
Yeah.
Now, we, however, if we know, for example, if you look at this entire sales data, they have given the sales amount. Like for example, on D, let's say the first row, 0 row, okay? You see D 1932, there are 2 items which are sold, right? 1933, there were 4 items that sold. Now, to find out what those items are, right, all we need to do is we need to go to our calendar data, look up what is WMYRWK, right? Go to the cell data, use the WMWRYK along with the ID, item ID, and we know the price.
Yes.
So that means for every one of these IDs, we can come up with the total sales which was accomplished.
Yeah. For this ID, right?
Yeah, exactly.
And for total sales on each of the days, right?
Exactly. So we can actually, what we can do, instead of just, we could, we can create another sales train data frame where we can use, instead of use these integer values and calculate the actual sales that were made.
Yeah.
Right? So then we have the sale for each and every item for all those 5 years. Now we can do some analysis, because what we can do, we can sum up according to how much we want. Like we can sum up according to a week, sum up according to a month, sum up in different ways.
Yeah. Okay. Yeah.
But I think, you know what, we are going to a fairly interesting data science problem. Because this is the kind of messy data you will get in most data science problems. Like for example, if you'll take data from a store or take data from anything, they will just collect it as some Excel sheet which comes from their software, their sales software. So quite often you will deal with data like this.
Yeah.
So this is actually beginning to look a little interesting now.
Yeah, definitely.
Yeah, so at least what we can do, once we have this, we can start at least doing some exploratory data analysis to find out what's going on. So for example, we can plot according to different time strains, different kind of things to try to figure out how they change.
Yes. So maybe one thing, because I think this is just a week. I'm just trying to look at. This is one per week, right?
Yeah, so it's like this. They've given a code for every week. So if you look there, you see that the first 5, probably if you do a head 8, just do head 8 in that DF calendar. Yeah, do head 8.
Yeah. This we saw it already. It's a week number.
Yeah. It's so just exactly. So from 0 to 6 is 1 week. So basically what we have to say is that they have used this encoding to say that this is a particular week number.
Yes.
So what we need is, we need to know that if we can combine all these to create a data frame, right, of every item that was sold, right, we can sort of break it down into a complete data set. So we have to start breaking this and creating several data sets. That is, every sale that was recorded, when was it recorded, right? For what item, for what cost?
Yes.
Right? And similarly, the vice versa. That is, every item that was sold, when was it sold, for what cost? And the second thing which we can do is, we now have to start loading temporal data. Like for example,
let's just write it down.
I would say, okay, yeah, I mean, these are, yeah, go ahead, right, of course, no problem. I'm just, and of course, the others, please feel free to think of anything.
Thinking out loud.
Yeah, no, I'm just trying to bring the others in. If any of you have any ideas, feel free to just throw it in.
Yeah. So we'll try to form a data set which will contain the
basically every sale, contain every sale with the sale total amount, say sale amount, and the date of that sale, the ID of and what was sold, and where was it sold, of course. Basically details of every sale.
Okay. Contain details of every sale.
Details of every sale.
Okay. So for instance, because I understand, perhaps I understand why they have a kind of data set they have. For instance, I would say what they have essentially given us is what we might do with group buy.
Yeah.
So essentially, we would say, okay, look, what was the sales per day? Because it's not possible easy to give, for instance, for this day, what all sales happened. So they don't want to give that also, I think.
Yeah, I think so. That is also, it's a challenge after all. So.
Yeah.
It is probably a challenge also, so that's why.
Because it could be that they don't want to give, or it's difficult to pick it up. But what is essentially happening is, for a given day, there will be multiple sales in a single shop. So there will be, like, for a shop, if you just take a shop, and then maybe my suggestion would be we can take a single shop.
Yeah, that sounds okay.
And then just to look at that single shop and then do an analysis of what is going to happen in that shop for the next 28 days, which they ask us.
Yeah.
Because otherwise what will happen is we are now having so many things, and we can, if required, we can even say that we will restrict which type of items that we are going to look at.
Yeah.
Like for instance, I would say a single shop, and then we will only look at the item classifications and not the items, items themselves. Let's say, so there are multiple levels as well. I would say that I would just go for categories.
Okay. Yeah. Okay.
Because I think the categories are, let me just quickly check. BF sales train.
No, there's a
underscore train. Cat ID dot unique. So there are only three of them. Okay?
Exactly. Very nice.
What we can do is take, for a given shop, predict the sales price of hobbies, households, and food over the next 28 days.
Right.
That's it. So for instance, we can take, say, CA1, and that means we will know that we can pick it up also like Snap CA, not Snap TX or Snap WI.
Right.
So we don't need these. And then events we can keep the same. And this way we can build a data set which will focus only on a single shop, and we're still going to do the same sale price prediction, but this time we are going to focus only on the categories.
Yeah.
And then maybe if required, we can go further. I mean, I think breaking down this might be a little easier to start.
Yeah, sure.
Okay. Makes sense. Okay, perfect. Okay, so I will just write it down. For CA1, we will predict sale prices for category ID over the 2-week period. That's it. This will be the task that we can probably start.
Okay.
And for this, the step 1 will be to prepare data set that will contain only these.
Right.
So in this case, for instance, I would say in calendar, we will have to prepare. We can actually pare it down further to say that, for instance, here we had. Let me just look at this calendar new. We will pull down Snap and Snap WI and Snap TX. And and these two will pull down, and this will be calendar, and we will add to this calendar for this store ID in the sell prices. For this store ID, we will look at, because this is given as hobbies, we'll just do a split string, take the first one, and if it is equal to a category, and we will say this hobbies is category 1, foods is category 2, and another one is category 3. We'll put that categories, we'll create a categories, and so this CA categories, sale price, and the only thing is this, we have to synchronize it based on this week.
Exactly.
Perhaps we may not be requiring to do it per day. We'll probably have to do it per week.
Yes, we do. Yes, we do. But we will actually, the thing is like this, the sale price is there, but we do not know what was sold exactly unless we go to that sales train evaluation data. So for example, here, this is where we know what was actually sold, how many items were sold.
Yes. So maybe we'll have to do some jugglery to figure out how to combine this and this, because combining this, the calendar and this seems to be okay, except that we can only fit it per week. But here we have the day detail, and so we can. But do you think we will be able to pare down everything? Because the thing I see is, for instance, if you look at 1932, we can figure it out what week it is easily, and we can figure out what was sold, like, okay, this specific product and things like that. Do you think we can connect it perfectly to summing up the sale prices or something like that?
I think so. I think it shouldn't be a problem. Because it's like this. If you know
we can do that.
Yeah, that's it.
That will be a good challenge. That will be an interesting thing to put. How do you make sense of a data to do a specific task? Because right now we have a very neat task. So that I think we'll be able to do it. Yeah. Okay, that'll be good.
Okay.
We're already out of time.
I think, we've already. So anyway, I suppose we had a long session, but this is beginning to look a little more interesting than we started off with.
Yeah.
So, I think we can do quite a bit with this.
There was a Kaggle competition about Germany on this similar one, sales price prediction. And there the guys did this. I mean, I suddenly connected with that, saying that the guys focused on individual stores first, and then they started looking at correlation between stores.
Okay.
So in fact, without knowing where the stores are, they found that the geographical correlation between the stores by just looking at the data. When they did some analysis, they were able to come up with just a second, I will stop sharing. Yeah, so then they were able to really come up with an idea where they were able to look at the correlation. So it was very interesting. But anyway, I haven't read it. I'm trying to not to look at the solutions for this, because there are a lot of people who have posted.
Okay.
And but we'll see. This is, however, at least.
Okay then. Okay, all of you, thanks for coming. Otherwise, see you next week.
Thank you.
Okay, bye for now.
Bye.